we're going to solve a cubic equation, and it's this one. 2x cubed minus 3x squared minus 5x plus 6 equals 0. And I'm going to solve analytically without a graphing calculator. But if we were to solve this by graphing, one way to do that would be to replace this 0 with an f of x. So if we decide to rewrite this function, or this equation as a function of f of x equals 2x cubed minus 3x squared minus 5x plus 6, and we graphed this function, we could see where the function touches or crosses the x-axis and thereby find our solutions to this equation. Or maybe there's only one solution. We'll see what it is. The first thing we're going to do is find the zeros, which would be the solutions for this equation. And for that, we're going to use something called the Rational Roots Theorem. Okay. Rational Roots Theorem is that possible rational roots are going to be plus or minus factors of last term, this there, factors of last term over coefficient of factors of first term. And so what we're going to do is find a list, and I'll do this below. We're going to have plus or minus here in the numerator factors of our last term, which is 6. So what are the factors of 6? Well, 1 and 2 and 3 and 6. And over coefficients of the factor of first term, and the coefficient is 2, so we have 1 and 2. And so we make the combinations of these to find our list of potential rational zeros. So we have, first of all, plus or minus 1 over 1, which is 1, plus or minus 1 over 2. Next we have plus or minus 2 over 1, which is plus or minus 2. Next we have plus or minus 2 over 2, which is just 1. We've already represented 1. Then we have plus or minus 3 over 1. And then we have plus or minus 3 over 2. And finally, we have plus or minus 6 over 1, which is plus or minus 6. And we also have plus or minus 6 over 2, but we've already represented 3 here. So what we have is, we call these possible rational zeros. Next, we're going to use something called, I'm going to come up here and use something called the Remainder Theorem. And the Remainder Theorem is, if we say f of k equals the remainder function f of x. And so if we plug in a value, which they call k, into an equation in this case, we're going to find out what the remainder is. And if the remainder is 0, we know that the value k is a 0. So that's related to the factor theorem. So we're looking for zeros in this manner, and we're looking for 1 initially. If we find that, then we're going to have an easier time of it. And so the first thing we're going to do is test the easier numbers. So test x equals 1 is a 0. And to do that, we're going to say f of 1 is equal to, we're going to plug in 1, so 2 times 1 cubed minus 3 times 1 squared minus 5 times 1 plus 6. And so we have 2 minus 3. Well, 2 minus 3 is negative 1. Negative 1 minus 5 is negative 6. Negative 6 plus 6 equals 0. So since f of k equals 0, then f minus k is a factor. So therefore, x minus 1 is a factor, in this case a linear factor, of this cubic expression, 2x cubed minus 3x squared minus 5x plus 6. Okay, so now we're going to determine what we have left after we factor out this linear factor x minus 1. So we're going to use synthetic division. I'm going to put this 1 over here on the left and put the coefficients of our terms in the expression, which are going to be 2 for 2x cubed, negative 3 for x squared, negative 5 for negative 5x, and 6. So we're going to bring down the 2, and so that means we're going to have 2x squared. 1 times 2 is 2. Negative 3 plus 2 is negative 1. 1 times negative 1 is negative 1. Add negative 5 and negative 1, we get negative 6. And 1 times negative 6 is negative 6. So our remainder is 0. So we get 2x squared minus 1x minus 6. So we know that we have, we can rewrite our equation now as, we've already found that x minus 1 is a factor. So x minus 1 times quantity 2x squared minus x minus 6, that will be equal to 0. And now if we can factor this quadratic factor 2x squared minus x minus 6, then we will have the linear factors and we will have our equation solved. So we're going to say in the standard form, a is equal to 2, b is equal to negative 1, and c is equal to negative 1, or negative 6. And so I'm going to use the x method for factoring. And the x method is we put ac up here in the top and b down below. So a times c is going to be negative 12. And then b is negative 1. So what two numbers, which when multiplied together equal negative 12, but when added together equal negative 1? Well, I think 4 and 3 are going to be the ones that will work best. And since we need to end up with -1, we're going to need to have -4 here and 3. And next we're going to divide by a, and a is 2. So to the left, we have -4/2 simplified to be -2. And then 3/2 do not simplify. So what I'm going to have is, we're going to have this x minus 2 times quantity x plus 3/2. And we're going to use the bottoms up method on the right. So we bring down x minus 2, and we take this 2 and move it up to the x. So we have 2x plus 3. So these are our factors now. I'm going to write these down below. So we have quantity x minus 1. We have quantity x minus 2. And finally, we have quantity 2x plus 3. Those are equal to 0. Why do I say the word quantity? Well, I say it because verbally, even if we're not writing this, if I say quantity x minus 1, you should be able to picture in your mind that the two terms I put together as quantity, you're going to have separated by a plus or minus sign. So it's a way of verbally following, even if you don't visually see what's going on. And so using the zero factor property, we can set each one of these factors equal to 0. And the zero factor property means anything times 0 equals 0. So we have x minus 1, that's equal to 0. We have x minus 2, that is equal to 0. And finally, we have 2x plus 3. That will be equal to 0. And solving for x, if we add 1 to both sides here, we have x is equal to 1. Here we have, on the middle equation, we have x equal to 2. And the right one here, if we subtract 3 first, then we have 2x equals -3, and then divide by 2. We have x right over here. X is equal to -3/2. So these are our solutions. Okay. Okay, we have these two here, x equals 1, x equals 2, and also x equals -3/2. So that's narrowed down. I want to lastly show you by graphing how it's done. I previously entered this as a function, this expression as a function, and you press enter, and I do not get it. What I need to do is I need to put a cube there. So I'm going to go back to tab, up here. I'm going to change that thing up there to a cubed. And when I do that, I think we'll be in a lot better shape. There we go. So here on the left, we have -3/2 between x equals -2 and x equals -1. And then on the right side of the y-axis, we have x equals 1 and x equals 2, where our other zeros occur. Good luck on this and all your other endeavors. And as always, thanks for viewing.